Imagine a professor pacing back and forth across the front of a lecture hall. If they walk a total of 150 meters during the class, but end up standing in the exact same spot where they started, did they actually go anywhere? Look at this diagram. As the professor moves, the total distance counter tracks every step taken, climbing to 150 meters. But notice the displacement arrow below it. Because the professor ended where they began, that arrow stays at 0. One measures the length of the path, the other measures the change in position. We define that change in position using this formula. Delta x equals x final minus x initial. Delta simply means change in. To find the displacement, we only look at the start and the end. The 150 meters of movement in between doesn't change the final result. To calculate these positions accurately, we choose one direction to be positive and the opposite direction to be negative. Usually, we assign positive to the right and negative to the left. Defining these directions turns a simple length into a specific coordinate. It allows us to track not just how far something moved, but exactly where it is located on our map. Let's apply this to a more complex trip. A cyclist rides 3 kilometers west, turns completely around, and then rides 2 kilometers east. We'll start by assigning east as positive and west as negative. We place our cyclist at the 0 mark to establish their initial position. To calculate distance traveled, we add the 3 kilometer and 2 kilometer legs together. This gives a total distance of 5 kilometers. This 5 kilometer total tracks the path and the effort expended, but it doesn't describe where the cyclist actually stopped. To find their final location, we have to look at the displacement. To find the displacement, we identify the 2 coordinates that matter. Our initial position, x0, is 0. The cyclist moved 3 units west and 2 units back east, which leaves them here at the -1 mark. This is our final position, x final. Use the displacement formula on your screen to calculate the final answer. Pause the video now to try it yourself. Let's run the calculation. We take -1 and subtract 0, resulting in a displacement of -1 kilometer. That negative sign indicates direction. Because we defined west as negative, the cyclist ends exactly 1 kilometer west of where they began. By using signs to represent direction, displacement gives us a net result that accounts for every turn and change in the journey. Sometimes we only need the size of that change, not direction. Stripping away the negative sign gives the magnitude, exactly 1 kilometer. This trip yields 3 distinct numbers: 5 kilometers of total travel, -1 kilometer displacement, and 1 kilometer magnitude. To keep these clear in your own problems, remember these 3 steps. First, establish your positive and negative directions. Second, calculate distance by totaling the entire path. Third, solve for displacement by finding the difference between your start and end coordinates. Differentiating between these 3 ways to measure movement is the baseline for one-dimensional kinematics. Mastering these definitions now ensures your data remains accurate as the problems grow more complex.